Okay guys, we're getting closer to the end. We're at 6.8. We are back to binomial experiments, but now it's when the probability is not 50-50. We're not tossing coins. We're not taking true and false tests randomly. This is something where the probability of being right-handed is more likely than being left-handed. Or in this case, we're going to assume that there's this student. I don't know who he is, but could be that his name is Reese and he plays basketball, and he's going to take 10 free throw shots during a game. And we want to find out the probability that he makes exactly 7 of them if we happen to know his lifetime average is 76%. Alright, so the way we do this is, I think, most easily explained if we just break it down into blanks. We've got 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright? And I'll start off with an easier version of this. What if we were to say, what's the probability that he makes all 10 in a row? We'll do that as a little sample first. And that would just be the chance of making his first free throw is 0.76. It's 76%, right? That's percent means over 100. So 0.76 times 0.76 times 0.76. Well, that's all the way down the line. So we would say that is the probability of making all 10 free throws would be equal to 0.76 raised to the 10th power. And I can take and put that into a calculator, and it would be 0.064. 0.0, whoops, that's a 0, 064, or about 6%, 6.4% to be more precise. But so Reese is good, but to make 10 in a row is still going to happen less than 1 out of every 10 times that he has a game where he takes 10 free throws. If we're going to now think of it where he has 3 misses in there, somewhere in his 10 shots he can miss it 3 times and make it 7 times. It could be that he makes the first 7 and then the last 3 he misses. And the probability of him missing then is 0.24 and 0.24 and 0.24. So I could have 0.76, 0.76, 0.76 all the way down the line, and then 0.24, 0.24. And that would give me the probability, but it would be the probability only of him making the first 7 and then missing the next 3. It's only one way that this can happen. He could make 1 and miss 1, and then make 1 and miss 1 and alternate, or he could miss the first 3 but then make the next 7. So really the question is, how many different ways? How many ways is there to mix up 3 things and 7 things in a total of 10? To mix 7, I'll do 7 plus 3 things. I hope that shows up on screen, but that's what I'm saying. How many different ways can I take 7 things and 3 things, like 7 heads and 3 tails if I have coins, and mix them up? Well, guess what? We're back to Pascal's triangle. There's a total of 10 things here, and I'm looking at 7 of them. And you go back to Pascal's triangle, which I have right here, and I go down to row 10, and I'm counting in from 0 things, 1, 2, 3, 4, 5, 6, 7, and I'm at 120. That's counting in 7 is the same as counting in 3 because of the symmetry, so I just counted in 3. So 0, 1, 2, 3 is 120. So 10C7 is equal to 10C3 is equal to 120. Alright? So there are 120 ways I can mix up this pattern. So what I do is I just multiply these all together and then multiply it by 120. Or written in simplified mathematical terms, I'm going to erase this now, my 7 blanks and my 3 blanks. The way I would write this is I will take 0.76 and I'm going to multiply that 7 times because I'm interested in the 7 shots happening to go in, times this by 0.24, and then it's always the number of times you miss, or the complement of that number, and then it's going to be multiplied by, in this case, 10C3. Or you'll see it's going to be the total of these 2 numbers, and then either one of these 2 numbers, because 7 and 3 will give you the same result there. Multiply that all out in this case, and you will get 24.3 or 24.3%, very close to 24.3% or 0.243. You could try this then with another combination. Suppose you want to find the probability that Reese makes 8 free throws. What would change then? Well, this becomes 8, and that becomes 2, and then that becomes either 2 or 8. It doesn't matter. It'll give you the same answer. What would be the probability that he makes 9 free throws out of 10? Well, that becomes 9. That becomes 1. We don't need to do it. And then this becomes 10C9. And then finally, if he makes all 10, this would become 10. This becomes 0, and any exponent raised to 0 just becomes 1. And 10C10 or 10C0 is just 1. So it just becomes this to the 10th times 1 times 1. And that's what we had down here, is just that to the 10th. So you can see it's consistent. It makes sense. All right? So why don't you pause the computer and actually crunch the numbers and find out what it is if it's 8 free throws. Find that out. Okay? Pause me. And then come back. And now hopefully you've done it. And you've just determined that when this is 8, and this is 2, and this is either 8 or 2, you're going to get 28.8% for that one. 28.8%. If I do it with 9 and 1, I get 20.3%. So this is the probability of 7 free throws going in, this is 8 free throws going in, there's 9, and then this is 10 free throws. So you are going to get a question on the test or a quiz which is going to be worded like, what's the probability that Reese makes 7 or more? 7 or more of his free throws. And what you have to do is find each of these cases, 7, 8, 9, and 10, and then just draw a line and add them all up. And just to guesstimate it here, I don't want to spend too much time. It's 2, 4, 60, 72 plus 6 is around 78, 79%. And we add up the decimals, very close to 79% of the time. Reese is going to make 7 or more of his free throws, okay? He's that good. All right? Good luck.